Okay, today we're going to be talking about equivalent fractions. Okay, equivalent fractions, 1 1/5 and 2/10. These are considered equivalent fractions. That means they have the same value. When plugged into a calculator, if you did 1 divided by 5, you'd get out a value, and 2 divided by 10 would give you that same exact value. So even though the fractions don't look alike, they still are equivalent fractions. Lowest terms means that the numerator and the denominator are relatively prime to each other. So the fraction in lowest terms up here is 1/5. So 1/5, the 1 and the 5 do not have any factors in common with one another, whereas 2 and 10 do have factors in common. Okay, so let's look at simplifying and reducing, or reducing, to divide out any factors that are common to both numerator and denominator. Let's do an example. Let's do 8/16. Okay, looking at 8/16, first off, let's look for the GCF. How do we find the GCF? Well, we can use the division method, where we had 8 and 16 in the division bars. And what's common to both 8 and 16? Well, you see a 4, that's great. Divide a 4 out and go, okay, that means that there's a 2 here, a 4 here. There's still factors in common there with 2 and 4. So make sure you factor everything out. A 2 left, it gives you a 1 and a 2. So the GCF is 4 times 2. 4 times 2 is 8. So our GCF is 8. What are we going to do with a GCF of 8? Well, GCF of 8, the first method, using the GCF method, or using what I call dividing out, we're going to have 8/16. We're going to divide both numerator and denominator by that GCF. Okay, what happens there? 8 divided by 8 is 1. 16 divided by 8 is 2. Final result being 1/2. That's lowest terms. So 8/16 and 1/2 are equivalent fractions, but 1/2 is lowest terms. Okay, so that's always our goal. That's reducing completely or simplifying completely. Another thing we can do, if you want, is with 8/16 we can write it as 8, which is the GCF. 8 multiplied by what number gives you 8? Well, 8 multiplied by 1. And how about the denominator? 8 multiplied by what gives you 16? Well, 8 times 2. So this fraction here that we've got right here is equivalent to this right here, because we've just written it out more as a factored form. So in its factored form now, what you see is that each numerator and denominator have an 8 in common. So can we get rid of those, right? If they're common to each, then we can eliminate them. Okay, and what are you left with then? Is 1/2. Same thing. So it doesn't matter how you went about doing it. Okay, what would happen if I didn't use the greatest common factor? Okay, this is something else that we want to talk about. What would happen if I had 8/16 and I didn't use the greatest common factor? Let's say I divided out a 4. Okay, if you divide out a 4, then you look and you go, okay, 8 divided by 4 is 2. 16 divided by 4 is 4. What you have to make sure is that you always simplify completely. So if you look at this, we're not completely simplified here in this last case because there's still factors in common to both numerator and denominator. So you still have to divide out a 2. So when you divide out a 2, you're left still with a fraction of 1/2. So no matter what, you can't go wrong any of these ways that you go about doing this. You'll still come out to the final answer. Something else I want to show you here is using the division method. Notice here that what you were left with was 1 and 2. We're going to go over this a little bit more deeply as we go over through the next sections, because writing it out as the numerator here and the denominator here, you'll end up with the numerator here and the denominator here. Okay, so let's go on to the next example. Okay, you try it, number 1. Let's see here. Simplify completely. Okay, what's the GCF of 6 and 14? Are you able to do those in your head now? The GCF between 6 and 14 is 2. So if that's 2, then what you can do is you can say, okay, well, 6 is the same as 3 times 2, and 14 is the same as 7 times 2. And so what do we get out? We get out, cancel those 2 out, and we get out 3/7. That's the final answer. So That's one method of doing it. You could have also put the division symbol, divide each by 2, and you'd get the same result. Okay, so what's the GCF here between 35 and 45? Well, the GCF between 35 and 45 is 5. Okay, again, could you have done division method like this and said, okay, what's common between 35 and 45? Absolutely, you divide out a 5. What's left when you divide 5 out? 7 and 9. So actually what you're able to do here is, instead of writing the way that I would have written it, was 5 times 7 over 5 times 9, canceling out those 5s to get 7/9 as the answer. Do you see 7/9 written right up there in the division method? It's right there waiting for you. So you can definitely use that method. Okay. One thing we can also do is we can also do it more in our heads. Is we can look here and say, okay, looking here at, you try at number 2, 30 divided by 996. Okay, looking there you go, well, I know that each of them have a 3 in it, so what happens if I remove a 3? Well, dividing out a 3, that's one thing you can do. And you can, as dividing out a 3, you're going to get 10 over, and what is 96 divided by 3? That's going to be 32. So now you're left with that. Now, we did not use the GCF there. We just used something that we knew visually that we could look at that was common between the two of them. Well, now looking here, I go, well, this is not simplified completely, so we need to finish this off. Let's divide each by 2, because there's still a 2 in each of those values. So dividing each by 2, you end up with 5 over, and then what's this one? 16. 32 divided by 2 is 16, so 5/16 would be your answer. Okay, again, you could have used your division method to do that, and it would have made things a lot quicker. Okay, how about this one? 60 over 150. Looking at this, something I want to talk about is 60 and 150 each end in a 0. What you can do, whenever something ends in zeros, you can mark this straight through the zeros, and the zeros can vanish. So you're left then with a fraction of 6 over 15. It's just like dividing out a 10. Okay, it's like dividing each numerator and denominator by 10. Now you're left with 6/15. Okay, what we can do now, this is something your book also does, is they look and they say, okay, there's a 3 in each. Well, if I'm going to remove a factor, we're going to do remove a factor of 3 from each. If I remove a factor of 3 from each, I'm left with a 2 here, and I'm left with a 5 here. This gives me an answer of 2/5. That's another thing you can do more in your head, math, as opposed to writing it all out. Okay, so a couple different ways to go about solving these problems. Okay, so, oops. All right, let's look at this. You try at number 3. Simplify completely. 75 over 90. Let's use that division method that I was just talking about on the last page. Let's get the answer this way. Let's make it the easiest way to go is by doing division method. You write your numerator here, and you write your denominator here, and your numerator and denominator will be sitting at the end. The lowest term one will be sitting at the end when we get done. Okay, what's common to each of those values? What's common is a 5. We see a 5. So let's divide out a 5. 75 divided by 5 is 15. 90 divided by 5 is 18. Okay, is there anything else in common with 15 and 18? Yes, there's a 3 in common. So dividing a 3 out of each, you're left with a 5 here and a 6 here. This still is your numerator and your denominator. And since 5 and 6 are relatively prime to each other, that is the fraction in lowest terms. 5/6 is what we're looking for. Okay, so let's do that again with 32 over 104. So 32 and 104 in your division bars, you do your numerator here and denominator here. And what's common to each? Well, looking at those two numbers, you might not see anything common. You might go, oh, what do I start with? Well, both of them are even. Divide out a 2. So dividing out a 2, you're left here with 16 and here with 52. Okay, so now looking at those two numbers, are they both even? Yes, so by that division, those divisibility rules of 2, as long as those two numbers are even, you can continue to take out a 2. So continue to divide out a 2. 16 divided by 2 is 8, and 52 divided by 2 is 26. Both even again, so continue with dividing out a 2, and you're left here with 4 and 13. Okay, so what's left over? 4 and 13, there's your numerator, there's your denominator. You don't need to go through the work of saying divide numerator by 8, divide the denominator by 8, and physically doing those divisions. You've already done it. You're left with the answer of 4/13. That's all you have to jump to. You no longer have to do this division stuff. We can erase that because you're done as long as you use the division method. Okay, let's look at you try it number 5. Now this one has variables in it. So let's look here. What we can do is, looking at the numerator and denominator, look and see is there anything common to both numerator and denominator. Well, they each have an A, so you can cancel out those A's. Since there's one A in each numerator and denominator, they will divide out. Okay, how about 8 and 12? Is there a common factor between 8 and 12? Well, each of them have a 4, so if you do that, divide out a 4, you're left with 2. Divide a factor of 4 out here, or remove a factor of 4, and you're left with 3. So that leaves you an answer of 2/3. Okay? How about the next one? Let's go to B. In B, I'm going to write something out. I'm going to write it out as negative. Let's write out negative 12, and then P is the same. P squared is the same as P times P. All over. Now here we have negative 60 MP. Okay, what happens with the negative signs? Well, the negative signs are gone because 2 negatives make a positive, so our result will definitely be positive. Okay, how about the P's? Look at, there's one P in the numerator and one in the denominator, so those can cancel out. Okay, how about now, so we've already canceled out the negatives. How about the 12 and the 60? What's common between 12 and 60? Well, if you don't know, you can always come down to the division, using this the division method, and you can say, well, I know there's a 6 in each. Okay, so you can do that and say 2 and 10, and you go up, there's still more, there's a 2, and you're left with 1 and 5. Okay, so there is a factor of 12 in each. Well, a factor of 12 in each would definitely give us a 1 here and a 5 there. So what's totally left in the numerator? Well, what's totally left in the numerator is a 1 times P, which is just P. In the denominator, it's 5M. Okay, and there's the answer, a positive P over 5M. Okay, so that's how you could go through and do that using variables. Be very, very careful of ones that have exponents on them. Okay, building up and reducing. Okay, so we talked in the beginning about the fractions 2/10 and 1/5. Okay, 2/10 can be reduced to 1/5, and we just saw how to do that. If we have 2/10, we say, oh, there's a GCF of 2. In here, in this case, the GCF is equal to 2. So we are going to divide each out by a 2. Okay, so what do we get? We get 1/5. So you do see that they're equivalent. Well, what if I wanted to go backwards? What if I wanted to build up the fraction 1/5 to 2/10? Okay, so how can I do that? All right, let's look at these. What do we want to do? Let's look at it in the You Try It number 8. I want to build it up to appropriate value. What I mean by that is I'm going to take 3/4. I want to multiply it by a fraction that will give me a final result of a fraction with a denominator of 24. The question you have to ask yourself is, what do I have to multiply 4 by to get 24? Well, that's 6. If you multiply the denominator by 6, you also must multiply the numerator by 6, which gives you a value of 3 times 6 is 18. So 18/24 is equivalent to 3/4. It's equivalent, but what we've done is now is we've built it up. We've taken it from being relatively prime to not being relatively prime. Okay, so look at B. What do we have to multiply by to get a denominator now of 24? So again, your question is, you're going to have to fill in those blanks. You're going to have to fill in all these things that I'm writing in right now for yourself of what do I have to multiply by? Okay, so what do you have to multiply by? 8 times what gives you 24? Well, 3. If you multiply the denominator by 3, you also must multiply the numerator by 3. Okay, because that gives you out this right here gives you out a value of 1. Okay, because as long as you're multiplying by a value of 1, you're not going to change the original fraction at all. Okay, so what is 5m times 3? Well, that's 15m. And there's your answer. Okay, what multiplied by negative 9c will give you a denominator with, let's see, how about the 28? Okay, 7 times what will give you 28? Well, In this case, it's 4. What you do to the denominator, you also must do to the numerator. So there's the 4. Negative 9c times 4. 9 times 4 is 36, and you have c, and you have to have the negative. Now, you could have written it easily as a negative 36c over 28. Okay, like that, where the negative's out in front of the fraction, or negative can be in the numerator, either way. Okay, so that's how you go about building up and reducing fractions, or we did both, building up and reducing the fractions. We did it both directions, so make sure you practice that. Good luck on this section, and I will see you next time.